Hi folks, this is Stan Forrester. We're just starting Module 5. If you take a look in the background, you can see that my Mardi Gras tree has just graduated to a St. Patrick's Day tree, so we're going to be celebrating that. While we're doing Module 5, this is where we're touching on electromagnetic radiation. We studied magnetism, we studied electric fields, now we're studying how they combine together, okay? And we call that electromagnetic radiation. Okay. One thing you're going to hear about is something called the speed of light in a vacuum. Okay, and you can give some speed of light in a vacuum in any number of different units, but sometimes it's just easy enough to call it one. You just units, and you can do that because we know that from general relativity that space and time are interchangeable. So space is measured in units of time, or time is measured in units of space distance. So a distance over distance is unitless, and you can just set that equal to 1. Okay, and then we use what are called beta factors. We would talk about something that's, say, 75% of the speed of light as being 0.7 c. Okay, these are 75% of the speed of light. And that just happens to be the speed of light in water. And that's interesting, especially to those of us who were nukes at one point. And there's something out there called Cherenkov radiation. Okay, and if you go out on the internet and you type in video of a reactor startup, like one of these university reactors or a research reactor, these things are at the bottom of a deep pool, and they'll pull the control rods out, start her up, and you'll see this huge blue glow. That's called Cherenkov radiation. Okay, and as the various radiation particles are given off by a reactor, okay, when a charge, particularly a charged particle, by a reactor or cosmic rays, okay, moves through the water at a speed greater than the speed of light in that medium. Okay, the speed of light in water is only 75% of the speed of light in vacuum. Okay, it's going to emit what's called Cherenkov radiation. It's going to shed some of that momentum and some of that energy as this characteristic blue glow. Okay, it's analogous to basically a sonic boom, where something moves faster than the speed of light in air. And just go ahead and check it out. It's an interesting thing. If you've never seen a film of one of these reactors being started up, it's pretty cool. Okay, so have a good one.